Welcome everyone to H.S.P in World of Chemistry. Right now we are going to find out how to find out total number of geometrical isomers. So all the formulas I will give you, whether the number of double bonds are even or odd, how to get the total number of GI, each and everything I will let you know. Yes, just within 10 minutes. So let's kill it, everyone. So see. Just a second, kids, just a second. 1 2 3 4 5 6. Now we are over here. Now just see, my dear students, if I say this is the double bond, can you see this double bond? Now sp2 hybridized carbon, this sp2 hybridized carbon, if it is attached with two different atoms or groups, that is A and B, and that side AB. Now it's not compulsory that AB on the right hand side. If it is being AB, then on the left hand side also it should be A and B. My dear students, it's not necessary. It's not at all necessary. Where it has gone? So yeah, it's not necessary that it should be A and B. If you see in this one, if it is A and B on left hand side, here it is A, here it is B, but there it is D and A. So what is required to show GI? That is the important thing. First of all, we have to understand that each sp2 hybridized carbon atom must be attached with different atoms or group. This is A, this is B. On the right hand side, A, B. That A is not equal to B and A is not equal to B. Now A and B in the second example, and this is D and E. Whatever they are, doesn't matter, but each sp2 hybridized carbon atom must be attached with different atoms or group, and that should be on both the sides, because double bond is formed by two carbon atoms. Now you must be thinking, so second one, how it will show GI? The second one will, this one will definitely show GI, but the type of GI is E and Z configuration. Right now we are not having that much of time so that I can explain E and Z, and that is not even required because the thumbnail is indicating that right now we are interested in to find out total number of geometrical isomers. So E and Z I will let you know later on, my dear students. First of all, if these two things are there, so definitely it's written over here that it will show GI. Now in which case it won't be able to show GI. Now see, this case it can't show GI. What is written over here? If you see, my dear students, just focus over here. This is A and A. That means the double bond is dead. B and B, both the side two atoms being same, so it can't show GI. Now if you see the second case, here it is A and B different, but on the right hand side it's A and A, they are being same. So if either of the sp2 hybridized carbon atoms having same type of atoms or group, that means that double bond is dead and it can't show GI. Then that means we will not consider such type of double bond to be the stereocenter. So double bond, if active, which case it is active? In these two cases it is active because this double bond is responsible to show GI. So this double bond is active, and this is our stereocenter, will be counted as one stereocenter, and there in this case it is not the stereocenter. So in such all these cases, total number of GI will be how much? Gets, you can say total number of GI will be 2 raised to power n, where n is number of stereocenter. Here it is 1, so 2 raised to power 1, 2. 1 cis, 1 trans, or 1 E, 1 Z. Now let's move on to the second slide, because now you must be thinking, sir, what are you doing? You have started teaching. Why are you not telling us the how to find out total number of GI in one go? First of all, we should understand which will show GI and which will not show GI. Then only we can find out that how many total number of GI will be there. Now let's see the second slide. Now generally people are thinking that GI is shown just by double bond. My dear students, if double bond is there, because of the pi bond there is restricted rotation, but if I talk about cycloalkanes, there is also restricted rotation and they can also show GI. My dear students, just see the cyclopropane. If I talk about, this is the cyclopropane, and cyclopropane, now In the cyclopropane, A is above the plane and A is also above the plane. That means this is cis. But once again, the same condition that on each carbon atom, if this is A, that should not be A, otherwise it can't show GI. So now this is cis, this form is cis, and another form, you see A is at the top and A is at the bottom. They are opposite side. This A is cis, means above the plane. No, sorry, not cis. This A is above the plane and that A is below the plane. That means they are on different sides. So they means they are trans. So one is being cis, this is being cis, and that is being trans. So they are, what is the relation they are holding? They are GI. So you see it acting as one of stereocenters. So the whole total amount is acting as one stereocenter. So 2 raised power n, that is 2 raised power 1, and 2 raised power 1 means you can see 2 raised power same 2 raised power 1, that is 2. One is being cis, another one is trans. Now my dear students, let me tell you one more thing. If you see this one, this one, this one, now on the same atom, if A and B are located or A and A are being located, that means this can't act as the stereocenter and can't show GI. So they should not be located on the same atom. They should lie on the different atom to show GI, my dear students. And remember that all GI are known as diastereomers, because GI are never the mirror images of each other. So diastereomers are not the mirror images of each other. GI are always diastereomers, but all diastereomers need not to be GI. Now let's move to the third page. Now this is our third page. You can see that it is oxime. This is known as what? Hey, oxime, my dear, oxime. Now in oxime, remember that this lone pair is also treated as one of the group. Now if hydrogen and OH, they are being on same side, we will call it syn. And if they are opposite, hydrogen and OH, they are opposite, we will call them to be anti. So these are 2 GI 2 raised power 1. So 2 GI, one is being syn, one is being anti. Why we are not calling it cis and trans? Because you know that the one side OH is there, another side hydrogen is there. They are not the same atom, but they are being on same side. So we cannot say that they are cis or trans. So scientists, they have used the word syn and anti. I hope that you're getting. My speed is too much because I have told you I will let you know each one of them just in 10 minutes. So my dear student, let's move to the another page. This is the most important thing, dangerous thing. We call it dangerous because even teachers get failed in such case. Now my dear students, just see to it. One double bond, let me draw it once again, because one double bond is in another color and it's not visible. Now I think it will be visible. Now let me change the color so that it should be properly visible. Now see my dear students, visibility is there. Now yeah, it's visible. Now my dear student, let me go back to that. So yeah, now see that first let me show you what's written over here. My dear students, everyone just see to it what's written over here. Minimum 8-membered ring. What's written over there? That minimum 8-membered ring is required to show GI with respect to double bond. That if the ring is there and you want to see that whether it can show GI or not with respect to double bond, that is what is required over there. Minimum 8-membered ring. That means if the 8-membered ring or more carbon atoms ring is there, that double bond is active and it will show GI, and that double bond will be considered as one stereocenter. So 2 raised power 1, 2 geometrical isomers will be there. One is being cis, another one is being trans. But if you see on the left hand side, my left hand side, these rings, they are either of 6 carbon, 4 carbon, 3 carbon, 5 carbon ring is not drawn. That means you people are really intelligent. So you can understand 3-membered, 4-membered, 5-membered, 6-membered, even 7-membered ring is there. And if the double bond is there, that these compounds won't be able to show GI because the ring is having too much of strain if its transform is being formed. What are you talking about, sir? We are not able to understand. Bhaiya, let me tell you that these compounds will always exist in cis form only. Why? Well, how can you say such cis form? See, this bond is going this side, so hydrogen is on this side. This bond is going this side, hydrogen is on this side. So both the hydrogens are on same side. That they are cis form. These such type of compounds exist only in their cis form. they never exist in that transform, and that's why I'm telling you they won't be able to show GI. If you want to see GI in these rings, then the ring must be of at least, yes, 8 membered. Now my dear students, let me show you next page. Now this is really awesome thing. This is known as allene. What do you call it? Allene, my dear student. These are known as allene because we know that earlier the double bond, single bond, double bond, single bond was coming, but here in this case the continuous double bonds presence is there, so we call it allene, or you can say cumulated system. Cumulated system means that pi bonds are not being separated by single bond. These pi bonds are continuous. Now in this case, by chance in allene, if you're forgetting anything in your examination, so just remember God to show GI, odd number of pi bonds should be there. If you see this first case, there even number of double bonds are there, so it can't show GI. The first one can't show GI because even number of double bonds are there. But in the other two cases, if you see clearly that pi bonds, they are being odd, but then also this case can't show GI. Why? Because if this is A, this is B, but their A and A are being same. Remember that H.S.P to a hybridized carbon must be attached with different atoms or group. That was the first condition, my dear students. Now if you see the second one, the number of pi 1, 2, 3, they are being odd. And if you see, this is being A, this is being A, this is being B, this is being A, this is being B, they are being different, so it will show GI. I hope that it's very much clear to each and everyone. But this whole together from here to here will be considered as to be one stereo center, so 2 GI, one is being cis, one is being trans, just 2 stereo center. I hope that everyone, is it clear? Now you must be thinking, sir, why the first case, when the pi bonds are even, it is not going to show GI? It's looking very simple, sir. It should show GI, but my dear students, let me tell you, it's a cumulated system. If you draw the structure, then the plane of A and B on the left hand side and right hand side, they are not same, so the compound must be planar. Sir, I am unable to understand anything. I will make separate video on allene for its visualization. Right now I have promised that just in 10 minutes I will explain each and everything, so I can't make a visualization of this. Sorry guys. So yeah, next video you can let me know that thing in the comment section if you really want to have visualization of allene, why the pi bonds, they are being even, they can't show GI, why they are not in same plane. Okay, now my dear students, next slide. This is really awesome slide, and this is going to be the second last slide. Now my dear students, the time has arrived when to tell you how to calculate total number of GI, because now we are aware of each and everything. So case number 1, once the terminal atoms are being different, what you're saying, sir, terminal atoms, how to understand? My dear students, just see from here to here, this is having double bond. So leaving the double bonds, you see the part is being left, that is being R1, and the part that is there, R2. One side it's methyl, another side it's being ethyl. It can be chlorine, bromine, methyl, chlorine, whatever. What I say, that R1 should not be equal to R2. Then the total number of GI formula is 2 raised to power n, and where this n is the stereocenter, or you can say the number of active double bonds. So you see 2 raised to power n. Now you will say, sir, even or odd, whether they are being even or odd doesn't matter if the terminal atoms are different. So see, in the first case, these pi bonds are 2, 2, 2, so 2 raised to power 2, that is 4, 4, right? And in the second case, if you see, the number of double bonds, they are being odd, but this is not allene. Remember that I have told you allene was having separate system, and that was counted as just one stereocenter, but here 3 stereocenters are there, 1, 2 and 3. These are 3 stereocenters, so 2 raised to power 3, that is coming 8. And remember that here also R1 is not equal to R2. Now next slide, here see case number 2. If I talk about, my dear students, case number 2, why I'm calling it to be case number 2? When terminal atoms or groups are being same, then we will consider it to be case number 2, and it holds a hell lot of weightage in the examination. You have to remember, when the terminal atoms are same, terminal atoms or groups are being same, we say that's case number 2. And case number 2, there are two sub cases: when the number of double bonds are being even, or the number of double bonds are being odd. That is two different situations. What I'm telling you, remember that when the terminal atoms or groups were not same, the odd and even was not having any value, but over here it holds a hell lot of weightage. Now the total number of GI formula is 2 raised to power n minus 1 plus 2 raised to power p minus 1. Now you must be asking, what is p, sir? Remember that if n is even, then p is having different value. If n is odd, p is having different value. What is that value, sir? Just to let us know. Okay kids, just wait. 1 2 3 4 5 6, same. So see, it's over here. The x case, n is even. When n is even, p value, you can see p value is n by 2. Where it's written, sir? It's over here, my dear students. P is equal to n by 2. Now you see this is methyl and that is also methyl. So R1 is equal to R2. R1 is equal to R2. They are being same. So now apply 2 raised to power n minus 1, 2 raised to power p minus 1. So 2 raised to power minus 1, 2 raised to power 2 minus 1, and 2 by 2. 2 by 2 is 1, 1 minus 1 is 0. And anything with value power is being 0, that comes to 1. So 2 raised to power 0 is coming 1. So 2 plus 1 is 3. So a little less than the earlier case. Yeah, if the R1 and R2 is not same, it was 4, but here 3, definitely. Now what's the reason, you must be thinking? So once again, let me know in the comment section if you are interested in a reason. Okay, everything is having a reason, but if you want to know what's being the reason, you have to write down in the comment section. Now the last slide, but not the least, it is really the last one. Case number 1, y n is odd, p is equal to n plus 1 by 2. Now by chance, if you're forgetting the examination, so odd value is not exactly divisible by 2, so something you have to add, so please add 1. That is the way, that trick. Now see, apply the formula. R1 is equal to R2. It's very clearly given over there. Tangy. Total number of GI is equal to 2 raised to power n minus 1, 2 raised to power n plus 1 by 2 minus 1. So 3 plus 1 divided whole by 2. 3 plus 1, that is 4. 4 by 2 is 2. 2 minus 1 is 1. 2 raised to power 1, 2. 2 to the power 2, 4. 4 plus 2, 6. Yeah. How much you have liked this session? Do let me know at the last. And whatever is required, the visualization power, any formula, anything you are unable to understand, do let me know. Your Baba H.S.P will solve that. All the best.